Alright guys, so I saw that Professor Ozturk updated his file. He made a modified version which included questions 3, 4, and 5, and then he updated it again to only have problem 3. And I want to show you guys how to do problem 3 because it seems like this is also going to be on the next quiz. So for problem 3, it's asking find the Fourier transform of the following energy signal xt, and you just have a square wave over here between 1 and 2. This is a very, very simple problem, and there was problems like this on the last quiz. If you were to find the first problem, if you were to find that answer using x0 and xn, you'll see that this is very similar, but if you found it using a0, an, and bn, well, I'll show you guys anyway. So this is, let me just show you guys how to do the general equation for this. So it's negative infinity to infinity, xt. It's really not too hard of a problem. So x to 2 pi ft dt. So this is a general equation for the, for this type of problem. To find the specific equation for this, it's going to be xf is equal to, the bounds will change. This is not from negative infinity to infinity, it's just from 1 to 2. And then we have xt. So this is a flat line at 1. So x of t is just equal to 1 times e to the negative j 2 pi ft. So I just didn't write the 1 in here, but you could just write that like this. Dt. Alright. And so now we have to integrate this, and just to remind you guys, if you have e to the negative j 2 pi ft, let me just write the general equation over here. If you're taking the integral of e to some value times t, and let's say a is a constant, then it'll be, let me actually write this in a different color so I could circle this later. So you have the integral of e to the at, which is equal to 1a e to the at, right? So this is just a general formula. So we're going to use that here. This negative j 2 pi f, all of these numbers are going to be treated as a constant a. So for this problem, we have x, whoops. Why does this not want to change? Hold on. There we go. So for xf is equal to the integral of 1 to 2. We have, actually we are solving out the integral, so this goes away, and it becomes negative 1 over 2 pi f, j 2 pi f actually, j 2 pi f, times e to the negative j 2 pi ft from 1 to 2. Right? So you can see that these are very similar. The only thing is that there's a negative here, so that'll just go on the outside over here. Whoops. Let me just make this bigger. Alright, so this is pretty much the same thing. And now we just have to plug in the values from 1 to 2. So over here, you have xf. This problem over here on the outside, that's being multiplied by this, and we're plugging in values 2 and 1 into this part, so we're just going to take that out. So 1 over j 2 pi f, it's going to be multiplied by this, which is going to change. So we have e to the negative j 2 pi f times 2, and this is going to be minus e to the negative j 2 pi f times 1, right? And with that, the only thing left to do is just actually multiply the 2 and the 1 by 2. So let me just rewrite this. This is going to be the final part. So xf is equal to negative 1 j 2 pi f times e to the negative j 2 pi, not 2 pi, it's going to be 4 pi because 2 times 2 is 4, so 4 pi f minus e to the negative j 2 pi f. 2 times 1 is 2. Alright, and this would be the answer to this type of problem. Now, I'm not so worried about this type of problem. This is very simple. You just have an integral for e, and that's it. This can take you maybe a few seconds to do. What I'm worried about is if you don't have a flat line like this. What if it was actually something like this, right? So that's what I'm going to be doing for you guys now. In addition to this problem, I'm going to make up my own problem. Because, of course, the practice quiz is only for practice, but it's nothing, it can be nothing like the real quiz, so I'm going to give you guys a harder problem right over here. So we have this. Hold on. We have this graph right over here, and it's going to go down, right? This is going to go down to negative 1, and this is your x of t function. So, and this is from 0 to 1, all right? So from this, you can just immediately tell that this is negative t. If he doesn't give it to you, I mean, it's pretty obvious that it's negative t. There's no x-intercept, or the x-intercept would be 0, and it's going down. If I were to extend this line down, right, it's going down by 1 and going over by 1. So this is negative t, and we have the same function from before. Xf is equal to. The only difference is this is going to be from 0 to 1 this time, and x of t will now be negative t. So negative t e to the negative j 2 pi f t dt, right? So now we have t times e to the negative j 2 pi ft, and that is a very hard integral to do. All you have to do is just remember like this identity, I guess you could say. It's not an identity, it's just the actual integral for it, so just remember it like this. If you have the integral of t e to the at, you could write it in two ways. So you could write it when it's factored out, so e to the at a squared times at minus 1, or you could also write it like this when it's multiplied through, so at e to the at over a squared minus e to the at over a squared. And as you can see, I just multiplied e to the at over a squared over here by at, and also by negative 1. And that's how I got this over here. So with that being said, it's really just a preference of which you guys like to do more. I'm going to do it in this way. I just want to show you guys how to do it this way. So we have one thing that I forgot to show before. So this negative right over here is just going to go on the outside of the integral. This is the same thing as being multiplied by negative 1. And of course, if you have just a regular number, you could just take it out. So I'm going to write that as well. Xf is equal to 0. So this is going to be negative And this, oh, that looks like an equal sign. So this is going to be negative integral of t e to the negative j 2 pi ft dt. Right? So that looks a lot more like this problem over here. So now that we have that, what do we do? So we're going to integrate this, and I said I'm going to use this style because I want to use that style. So we have xf is equal to, and I have the answer right here, so I'm just going to copy it. So the negative stays on the outside. Then when we integrate it, this negative j2 pi f, that's going to act as our a, so we just have to fill that in everywhere we see it. So this is going to be negative j2 pi ft, and this is times e to the negative j2 pi ft divided by negative j2 pi f squared. Right. Alright, and this is minus e to the, what would this be? E to the negative j 2 pi ft over negative j 2 pi f squared. And this will be from 0 to 1. Okay, so we have this big equation here, but it's going to simplify very nicely. So it's better to do this like big equation now and practice with it now instead of trying to do it during the quiz, right? So this is your equation. After you do that, let me see. Is there anything else that I have to write? No. Oh, one thing I do want to simplify this because we can just simplify it. This can be simplified very easily. So if I have xf is equal to all of this, negative j 2 pi ft e to the negative j 2 pi ft. Of course, you guys can just simplify this in one step. You don't have to break it down into multiple steps. So the j squared is equal to negative 1, and negative 1 times negative is just a positive. So this is going to be a positive down here. 2 squared is 4. Pi squared is, of course, just pi squared. And f squared is f squared. Same thing over here. E to the negative j 2 pi ft stays the same. And this is over 4 pi squared f squared. Alright. And of course, you could just write that in to this step over here. You don't have to write it in. You don't have to break it down to 2 steps. So after you do that, what do you have left? Now you have to actually, this should not be from 0 to 2. This should say 0 to 1. Whoops. So 0 to all right. 0 to 1. There we go. All right. Now we just have to evaluate the integral. This is going to be pretty big, but it's okay. This is xf is equal to negative, let me just draw a really big bracket over here. So it's going to be the first part, so we're going to put in 1 to everywhere we see t over here and over here. So let's do that. Negative j 2 pi f e to the negative j 2 pi f divided by 4 pi squared f squared minus e to the negative j 2 pi f divided by 4 pi squared. 4 pi squared squared f squared. There we go. Finally got it. All right. And that's going to be subtracted by the evaluation for 0. So let's take a look at this right now. If I plug in 0 to this first part over here, where do we see t? T is on the outside over here. So if I plug in 0, this will all, this is all going to go away. This is all going to go away. It's going to be 0 over 4 pi squared f squared, which is equal to 0. So this first part is 0, and that's minus e to the whatever this is times 0. That'll be e to the 0, which is just simply 1. So this is 1 over 4 pi squared f squared. Whoops. Okay. So we have that equation now. What else can we do? The only thing else I could see, this is going to be, this times this is going to be a positive. So I'm going to rewrite this, but I'm not going to rewrite the whole thing because it's way too long. xf is equal to negative, it's going to be whatever is inside this parenthesis, plus 1 over 4 pi squared f squared. Right? Because this negative and this negative cancel. So, after you do that, then it's very simple. It's very simple from here. This is basically the answer. The only thing else we could do is just simplify right now. So we have a 1 over 4 pi squared f squared in every single term over here, in this one, and in this one. So I'm just going to take that out. You have xf is equal to negative 1 over 4 pi squared f squared. And that's going to be, what this is going to be, minus j2 pi f. So minus j 2 pi f e to the negative j2 pi f e to the negative j2 pi f. And the next part is going to be minus e to the negative j2 pi f. Minus e to the negative j2 pi f. And this last part is going to be plus 1. Right? We take out a 1 over 4 pi squared f squared over here. It's just going to be 1. I mean, you could leave it like this. You could leave it like this, right? This is fine. You could simplify it. You could multiply this negative through. It's whatever you guys want to do. I mean, you have a lot of free will to do this type of problem, but you do want it to get to something similar to this. So this is like a harder problem. Of course, you guys should memorize this equation for the test, for the quiz. This is a very useful equation to use. I mean, of course, you had it in the last quiz, but just in case you don't know it, you don't remember it from the last quiz, here it is right now. So the only other thing I could do, so we got a little bit of a harder problem, which is possible to show up for the quiz. Let me just take it one step further, but we're not going to do the whole thing. So let's say you have something like this. I'm not sure if he gives you the equations, or the x of t, so let's just go like this. Let's say you have this line instead. And it's from 1 to 0. It's basically the same thing, but it's a little bit lower. This is at negative 1 this time, and this one is at negative 2. And this is your x of t, right? So you're thinking, Well, first of all, if he gives you this equation, then you're fine. This is not too bad. But if he doesn't give it to you, this is still negative t. Although if I were to extend this out, right, this is going to hit at -1. So the equation is going to be negative. I could actually keep that in. I don't mind keeping that in. This equation is going to be negative t minus 1, right? Y equals mx plus b. When you have this type of problem, you might see something like this. xf is equal to the integral from 0 to 1, so that stays the same. But you might see something like this. Negative t minus 1 times e to the negative j 2 pi f t dt. And you might be thinking, oh my god, we don't know this equation right here. We don't know how to integrate negative t minus 1 times a value of e, right? And you might panic. You might get scared on the quiz, and it's just like, I don't know how to do this problem, and you might even skip over it completely. Let me show you a helpful trick, just in case you don't remember from calculus. You have xf. Because you have a minus over here, right? You have, this is being, if you're either adding or subtracting, you could just split this up. So this is going to be 0 to 1, negative t e to the negative j 2 pi f t dt. And then you have plus the integral of negative e minus j 2 pi ft dt, right? And we know how to integrate this, and we know how to integrate this, right? If you were to just take out those negatives, it would look very similar to what we've done before. Negative 0 to 1 t e to the negative j 2 pi ft dt minus e to the negative j 2 pi ft dt. Right? We have integrated this one just right before this. We solved it out right now. So right over here. And this one was the first problem that we did. Right up here. So if you do see a problem similar to this on the quiz, don't panic. You know, just multiply it through, and it'll still be a simple problem. It'll be a little bit longer, right? You have to do both of them, but it'll still be simple all around. So thank you guys again for watching this video. If you have any questions, of course, leave it in the comments, leave it on YouTube, or you could DM me on Discord. That's fine too. But anyway, hopefully you guys all get hundreds. I'm hoping that everybody does well on this next quiz. And I guess have a good night, guys. See you later.